Yeah, you're welcome to techtalks.com, and we are still learning organic chemistry, and now we have gone to the IUPAC rules of nomenclature of organic compounds or hydrocarbons, whatever you call it, but it is nomenclature of organic compounds. Now it is important that we note a few things in the subtopic. IUPAC. What is IUPAC? Why was it developed? In the past, it was very hard to name because people would name the way they want, and each and every person would give you a reason that this is right because of this, and the other. But it became so synonymous that everybody would name according to himself, and you'd find one answer with so many answers which were wrong. So a body sat, and it was about governing the types of answers that come to given respective organic compounds. This is just an abbreviation. It is IUPAC. U-P-A-C. This I means international. International. Then U means union. Then P of pure. And applied chemistry. That's how I would write it in full, because this is just an abbreviation really. IUPAC stands for International Union of Pure and Applied Chemistry. So when a body sat, they devised the means of having rules that would govern the types of answers that would come for one given question. Now, it devised the rules that really govern the naming. And since we are looking at naming would be so much easier if we could understand the rules. Now, we don't mean that you go sit and cram rules. No, nobody can ask you to state the rules. But the questions which we set require somebody who applies the rules. So the rules must not be crammed, but understood. It is important to understand the meaning of the rules. We really need to understand the meanings of these rules. Now, rule number one talks about that when a learner or anybody or a chemist is naming an organic compound, should look at the longest continuous chain. The longest continuous chain. This longest continuous chain should become the parent. Should be the one to provide the parent name. It is from the longest continuous from which the parent name is derived from. We are saying that when we are naming an organic compound, should struggle so much to ensure that we identify the longest continuous chain. And it is from the longest continuous chain that from which we derive the parent name of that organic compound. For example, if we look at such a compound, take an example of that nature. When you look at this compound, we can look at this compound in terms of that. We can look at this compound in terms of this. We can also look at this compound in terms of this. I don't know whether that's clear. repeat it. We can look at this compound in terms of this one. We can look at this compound in terms of this one. Then we can also look at this compound in terms of this one in green. But our analysis is based on which one is the longest continuous chain. Now, let me start with this. This one will have carbon 1, 2, 3, 4, 5, 6. Now, this one will have 1, 2, 3, 4, 5, 6, 7. So you see, this is already 7, the other one is already 6. So that means the one with the 6 is already out. It is not the longest continuous chain. It is continuous fine, but not longest. We are having terms continuous, but again longest. A chain could be longest, but when it is not continuous. Chain could be continuous, but when it is not continuous. But somebody should really consider both cases. Now, looking at this, 1 means black. So this is 1, 2, 3, 4, 5, 6. Now, but when we take this direction, we'll have 6. When we take the other horizontal direction, we'll have 6. But when we move from the left towards right, then we branch downwards, we shall have a number of 7 carbons. So this one now becomes our longest continuous chain. Now, after looking at this as the longest continuous, it means whatever is the other side is a side chain. That's what it means by identifying the longest continuous chain. Let me write it in a clear format where we can observe it very well. This carbon 1, carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, carbon 6, carbon 7. So that is now our longest continuous chain, meaning that the whole of this one is a side chain. The whole of that is a side chain. And when we look at our side chain, using the idea of comparison between alkanes and residues, alkanes and alkyl groups, this is an alkyl group. Because when you look at this is CH3, CH2, it is one hydrogen less than the corresponding alkane, and therefore it qualifies to be called an alkyl group. So therefore, when we are to name the alkyl group or the side chain, then we shall call it ethyl. Ethyl becomes our side chain. So in other words, after identifying the longest continuous chain, The rest of the chains or sides attached to the parent, we refer to them as side chains, and normally they are normally alkyl groups. That is rule number 1. Rule number 2, talks about side chains. These side chains, we can call them side chains or we can call them constituents. Call them side chains or constituents. That if there is a side chain attached to the parent, for example, we said this is our longest continuous and we are referring to this as our parent chain. Then any other thing attached to the parent chain qualifies to be a side chain. If we don't call it a side chain, we can call it a constituent in singular and constituents in plural. So we are saying that in case there is a presence of a side chain on the parent, it is important that when naming we indicate the presence of the side chain. How do we indicate the presence of a side chain? Number 1 is by telling the name of the side chain, and number 2, indicating the position of the side chain on the parent. Position means on which number of carbon atoms is it? Is it on carbon 1? Is the side chain on carbon 2, side chain on carbon 5, exactly where it is. So we're saying that a side chain must be named. Named meaning we looked at how to derive the alkyl groups of the side chains of the residues. Should be named. Is it ethyl? Is it alkyl? Is it ethyl? Is it methyl? Is it propyl? 1. Secondly, on which position is that side chain? But we're saying that it is important that a learner tells us the lowest position of the side chain. There could be a possibility of having a side chain on carbon 1. There could be a possibility of having a side chain on carbon 2, 3, or 4. But which one is the lowest position of the side chain? Very, very important. Very, very important that we tell the position of the side chain. Now, having analyzed these two cases, then we can proceed and look at examples of a few or smaller compounds, how we name them. Examples now. Example could be a compound like that. Yeah, compound like that, rule number 1, we identify the longest continuous chain. Now, before we look at that, these bonds which are being written should be between carbon and carbon. I want to look at a case where somebody writes it like this. This bond is between carbon and nothing. There's between carbon and what? And nothing. And it is not between carbon and somebody could bring the bond here. It is not between carbon and hydrogen, but between carbon and carbon. So bond should be between carbon, just like I've done it here. It may not necessarily touch, but should be very close. So it may not touch, but should really be very, very close. Now, longest continuous. If I start from the left, going to the right, this is carbon 1, carbon 2, carbon 3. Carbon 1, carbon 2, carbon 3. So that one means that any of them can be a parent chain because all of them have equal number of carbon atoms. But if one of them had more number of carbon atoms, then the one with the higher number of carbon atoms would become the parent chain and therefore will give us the parent name. Secondly, identify the side chain. If this is my parent chain, then any other thing attached to that parent horizontal chain is supposed to be a side chain. Now, when referring to the side chain, we look at what is the name of that side chain. Then secondly, on which position is it in the parent chain. So when we do that, we should be able to say this is 1, 2, then it becomes, it is on the second position. Then we separate figure and word by a hyphen. What is on the second position is a methyl. Then after, this is a methyl on the second position. Then what is the name of the parent chain? The name of the parent chain is a hydrocarbon alkane with the 3 carbon atoms. Therefore, we shall call it propane. Yeah, that's example 1. Example 2. Yeah, that can be our example 2. So like I said, we first of all identify the longest continuous chain. We can do that by looking at, this is the carbon 1, carbon 2, 3, 4,